Figure has signed its first commercial deal and is sending its general-purpose humanoid robots off to start real-world work at BMW's manufacturing plant in South Carolina. Emerging from stealth mode just 10 months ago, Figure has developed its robots at a frightening pace. The company had prototypes up and walking within a year of development, thanks to a highly experienced team, and at an impressive speed too, compared with everything this side of the acrobatic Atlas bot from Boston Dynamics. A few weeks ago, the company announced another milestone, releasing video of the Figure 01 robot autonomously making a coffee in response to a verbal command. The robot figured out how to use that coffee machine on its own after watching a bunch of video demonstrations. And now, it's delivering on its promise to get the bots out there doing real, useful work as soon as possible. Under a freshly signed commercial agreement with BMW Manufacturing, Figure has started identifying initial use cases at BMW's Spartanburg plant, and has begun training the bots up for a staged deployment on site. It's not the first time autonomous humanoids have gone to work alongside humans. Amazon, for example, announced in October that it would start testing the Digit humanoid from Agility Robotics as a mobile manipulator carrying bins and totes around in warehouse situations where there's not enough space for conveyor belts, and older facilities that haven't already been custom designed with flat floors suitable for wheeled robots. But note here that Amazon is an investor in Agility, so it shares an interest in developing the Digit robot. Figure's deal with BMW is purely commercial, and that could make it among the first, if not the first, deal of its kind. Training has already begun in Figure's labs for the first tasks the 01 will start attempting at BMW, although the two companies are yet to announce exactly what it'll be doing on the factory floor. Certainly, the 01 isn't going to be making coffees. So the robot is starting to hit the road for a category of machines many expect will eventually free humanity from the yoke of physical work altogether. Humanoids are the same shape as us, they can access the same spaces and use the same tools. Early models might move awkwardly and act slowly and ponderously, but as the AIs underpinning their ability to act in the world develop and the hardware goes through many iterations, they should be able to see, think, respond, and act faster, better and stronger than we can. If you have ever wanted a robot to cook food for you, the day is not far away. This robot can perform multiple activities like cooking shrimp or organizing things in your house, making it a potential AI-powered housemaid of the future. Imitation learning has shown great potential in robotics, especially in tabletop manipulation. A team of researchers from Stanford University and Google DeepMind has made progress in this field by creating a mobile ALOHA humanoid system. Building on Google DeepMind's ALOHA system, this novel contribution addresses the high costs and technical challenges of training mobile bimanual robots that require careful guidance from human operators. The project also involved researchers from Berkeley University and Meta. It costs a fraction of off-the-shelf systems and can learn from as few as 50 human demonstrations. This system came out at a time when there was a significant acceleration in robotics, and the success of generative models partly enabled it. The mobile ALOHA integrates a mobile base and a comprehensive teleoperation interface to enable whole-body control. The system is designed to emulate intricate mobile manipulation tasks, which were previously challenging using conventional imitation learning techniques focused on tabletop scenarios. The robot is primarily used for data collection, laying the groundwork for acquiring knowledge and reproducing diverse bimanual activities. One of the key features of mobile ALOHA is its ability to simultaneously train with the established static ALOHA datasets, which sets it apart from regular robotic systems. The system achieves impressive success rates using a combination of supervised behavior cloning and 50 demonstrations for each task. While the robotic chef does impress with its abilities, there are still some outtakes where it bumbles and gets things wrong. Nonetheless, this is a significant development in robotic learning from instruction. It remains to be seen how AI will impact human jobs, but the current administration has taken steps to draft governance and guidance around the technology. The hope is to find a healthy balance that safeguards current jobs while addressing the potential for both promise and peril that artificial intelligence holds. Humanoid robotics has been evolving at a rapid pace, with several companies introducing advanced robots to the market. Recently, Chinese firm LimX Dynamics has also made significant progress in this field with the development of quadruped and biped robots. Now, for the first time, the company has showcased a test of its humanoid robot, codenamed CL-1. The robot has completed dynamic tasks such as climbing stairs, walking down slopes, and moving indoors and outdoors in different environments. CL-1 is one of the few humanoid robots capable of dynamic stair climbing through real-time terrain perception. The company has achieved this feat by utilizing sophisticated motion control and AI algorithms, proprietary high-performance actuators, and hardware systems. The biped bot is designed to serve as a platform for tackling cutting-edge technology challenges in humanoid robots. Developed from the point-foot bipedal P1, CL-1 started as a stable and efficient base for developing and testing motion control algorithms for humanoid robots. While there are limited details available regarding CL-1, LimX Dynamics claims to have advanced humanoid robot evolution by upgrading CL-1 with improved perception algorithms, enabling a full-loop integration of perception, control, and hardware. This integration liberates humanoid robots from the constraints of blind movement, allowing them to interact with their surroundings in real time. Recently, indoor and outdoor tests were conducted, where a robot was able to assess stairs, slopes, and curbs independently. It adjusted its gait in real time to traverse them without any incidents. The robot wasn't merely pre-programmed to move its legs in a precise manner that matched each of the specific challenges. The company has stated that it could perform this feat via a combination of onboard sensors, real-time terrain perception, motion control algorithms, high-performing joint actuators, and other hardware. Samsung revealed a bunch of new home appliances, technologies, and TVs at the CES 2024 event. One of the devices that attracted a lot of attention was Ballie, an AI companion robot that Samsung first introduced 4 years ago. Ballie has been revamped with new advanced features to help users intelligently navigate their lives by taking care of household tasks, displaying the day's events, and sharing weather updates. The updated Ballie features a new design, built-in projector, and integration with SmartThings, among other new capabilities that come with updated software. This AI companion robot runs on Tizen OS, which was previously only used in Samsung Smart TVs and the Family Hub refrigerator series, but has since been expanded to more device categories. The company's smart and premium monitors, as well as its new cooking range, microwave, and washers, now use Tizen. Ballie is a novel addition to Tizen, and the operating system helps connect with the user's other Samsung devices. This personal home assistant can connect to and manage home appliances to provide a helping hand to users in many situations, continually learning from users' patterns and habits to provide smarter, more personalized services. The robot can even send video updates of pets or loved ones to users' devices when they're away from home, providing peace of mind. Ballie can set the mood for any home activity, whether users are exercising, working, or relaxing. Since it runs Tizen OS and has a built-in projector, it can display a smart TV-like UI on any surface, such as the roof or a wall. You can watch movies or TV shows, stream music, control your smart home devices, and even answer phone calls, making life at home more productive and enjoyable. Also, this bowling ball-sized robot syncs with your Samsung account ID, which means it fully integrates with your phones, tablets, and other Samsung devices. You can also play games via streaming from the cloud through Samsung Gaming Hub. Samsung is planning to release Ballie in 2024, although we cannot be sure about the release date as it may take longer. It does indicate that the concept of robot assistants in homes could be closer than we think. When it comes to tasks like the exploration of unstructured environments, traditional robots may be stymied by obstacles such as uncrossable gaps. That's where the FiloBot comes in, as it grows like a self-supporting vine. Developed by scientists at the Italian Institute of Technology, the FiloBot is able to grow towards light sources and away from the pull of gravity, although it could also be set up to do the opposite, not unlike the tendrils of a climbing plant. The device has a conical head at the top, a power source or base station at the bottom, and a stem-like body in between. That body gets longer and longer as the robot grows, but how does it grow? Well, the FiloBot is continuously pulling a filament of 3D printing thermoplastic up from a spool in its base station into its head. That filament passes through a heated extruder in the head, which is slowly rotating relative to the body. In this manner, the robot 3D prints its own body in successive coiled layers of molten plastic, which bond together as they cool. That said, the body isn't printed in a uniform fashion. In response to light sensors, a gyroscope and other head-integrated electronics, the temperature, orientation and deposition speed of the plastic is continuously varied. In this way, the FiloBot is able to control the direction in which its body grows, always heading toward the light and away from the ground. The robot automatically winds around vertical supports when they're present, just like a vine winds around a trellis, allowing it to put less time and energy into growing a strong body when strength isn't needed. When no adjacent support surfaces are detected, however, in other words, when the head has reached an open space, the body is grown stiff and strong, so it can support itself. What stands 5 feet 10 inches tall, weighs 85 kilograms, and has 5-fingered hands with 12 degrees of freedom? That's right, it's the Kepler Forerunner humanoid robot. Manufactured by China's Kepler Exploration Robot Company, the Forerunner is designed to be a direct competitor to Tesla's Optimus robot. That said, it is a bit more expensive. Whereas the latest price estimate for the Optimus is less than $20,000, the Forerunner ought to go for about $30,000. One of the robot's big selling features are the proprietary planetary roller screw actuators in its arms and legs. These deliver up to 8,000 newtons of thrust to the elbow, knee, and ankle joints. The Forerunner perceives its surroundings via a group of sensors located in its head. These devices include a wide-angle binocular camera, a far-field array of 4 microphones, an accelerometer, and an AHRS or attitude and heading reference system. It can also speak to people via a synthetic voice module and stereophonic speakers. All of the sensory data is processed via Kepler's proprietary Nebula AI system, allowing the robot to navigate complex environments and avoid obstacles while walking across uneven terrain. Its hands can both sense and gently grasp objects, plus they also allow the robot to pick up and carry heavy objects. An exact lifting or carrying capacity hasn't been provided at this point. Several versions of the Forerunner will be available, aimed at applications such as manufacturing, inspection, high-risk tasks, outdoor work, plus robotics research and education. Production and shipping should commence in the third quarter of this year. Unitree, another Chinese company on this list, has also announced its first-ever humanoid bipedal robot called the Unitree H1. With a planned price tag of under $90,000, the H1 is intended to rival other humanoid bots such as those made by Tesla, Figure, and Agility Robotics. As far as basic specs go, it stands 6 feet, weighs about 47 kilograms, and can carry a payload of up to 30 kilograms. Joints in the hip, knee, and ankle give each leg a total of 5 degrees of freedom, while joints in the shoulder and elbow give each arm a total of 4 degrees. Unitree's own M107 motors deliver 360 Nm of torque at each joint. Flexible fingers are in the works. The H1 is able to see its surroundings in 360 degrees via a head-mounted Intel RealSense D435i depth sensing camera and a LimX MID360 LiDAR module. Dual Intel Core i7-1265U microprocessors analyze the real-time output from those devices, allowing the robot to walk over uneven terrain at a speed of over 1.5 meters per second. Unitree estimates that it should be able to run at up to 5 meters per second, that's 18 kilometers per hour, or 11.2 miles per hour. Power is provided by a removable 15 amp-hour lithium battery. There's no word on runtime. The company says that it should be commercially available in anywhere from 3 to 10 years. A team of researchers at the Korea Advanced Institute of Science and Technology, or KAST, have developed the world's first humanoid robot pilot that can fly an aircraft without modifying the cockpit. Called PIBOT, the humanoid robot can understand manuals written in natural language and fly a plane on its own. The robot could sit in a real cockpit and operate the various pieces of equipment without modifying any part of the aircraft. It utilizes AI and robotics technologies to memorize flight charts and emergency protocols. The KAST team says incorporating ChatGPT technology provides PIBOT with a distinct advantage. This means the humanoid pilot can already remember Jeppesen aeronautical navigation charts from all around the world, which is impossible for human pilots to do, and fly without error. Also, the PIBOT has memorized the full Quick Reference Handbook, which contains all the procedures applicable for non-normal and emergency conditions, such as a loss of electrical power or system malfunctions, in an easy-to-use format. The robot can respond immediately to various situations, as well as calculate safe routes in real time based on the flight status of the aircraft, with emergency response times quicker than human pilots. While existing robots usually carry out repeated motions in a fixed position, PIBOT can analyze the state of the cockpit as well as the situation outside the aircraft using an embedded camera. Because it's a humanoid robot, PIBOT can accurately control its robotic arms and various cockpit switches, even during harsh turbulence. Currently, the humanoid pilot can carry out all operations from starting the aircraft to taxiing, takeoff and landing, cruising, and cycling using a flight control simulator. The KAST team plans to use the humanoid pilot to fly a real-life light aircraft to verify its abilities. The project started in 2022 and is expected to be completed by 2026. The researchers are also considering commercialization strategies for both military and civil use. Robots are nothing but an automatically operated machine that replaces human effort. These robots can also take over unpleasant, complex, or health-threatening tasks that manual workers can perform. Nowadays, many companies are making android robots. A spin-out company from the Human-Centered Robotics Lab at the University of Texas at Austin Aptronik has unveiled Apollo, the alpha version of their most recent humanoid robot, on completing the 7th year of the company. The Aptronik company designs humanoid robots and has previously made more than 10 robots. Also, it was contracted to build a robot named Valkyrie for NASA. Apollo is the first commercial humanoid robot designed for friendly interaction, mass manufacturability, high payloads, and safety. The robot is a 5 feet 8 inches tall robot that weighs around 72 kilograms and can bear up to 24 kilograms of weight. It is integrated with a hot swappable battery pack. Each battery can last up to 4 hours, and it can continue with a simple battery change. It also can be plugged into charge or tethered for continuous operation. It is also equipped with LEDs in the head, mouth, and chest, all working together to communicate status. Apollo's body shape and size are similar to that of humans. This enables him to navigate human space and use our tools and equipment. It makes human interaction natural and allows for difficult or impossible tasks for other types of robots. Apollo is integrated with several sensors and is designed to be a safe robot. Similar to the robot's safety advantages over industrial robots, Aptronik's unique force control architecture provides safe movement around humans. This robot immediately stops any movement when detecting objects within the impact radius. The Apollo is a general-purpose robot designed to replicate anything humans can do, enabling humans to take higher-skilled roles. The robot software suite allows point-and-click control of your humanoid robots and automation by deploying and fully integrating various solutions into your warehouse and manufacturing operations. It will operate in warehouses and manufacturing plants soon, eventually extending into construction, oil and gas, electronics production, retail, home delivery, elder care, and countless more areas. It can perform many tasks, such as uploading packages in the trailer, picking cases, palletization, machine tending, and work cell delivery. Researchers at North Carolina State University have developed a new soft robot design that engages in 3 simultaneous behaviors: rolling forward, spinning like a record, and following a path that orbits around a central point. The new soft robots, called twisted Ringbots, operate without human or computer control, paving the way for soft robotic devices to navigate and map unknown environments efficiently. These twisted Ringbots are made of ribbon-like liquid crystal elastomers that are twisted and then joined together to form a loop. When the robots are placed on a surface that is at least 55 degrees Celsius, the portion of the ribbon touching the surface contracts, while the portion of the ribbon exposed to the air remains unchanged. This induces a rolling motion. The warmer the surface, the faster the robot rolls. The twisted Ringbot also spins along its central axis like a record on a turntable and moves in an orbital path around a central point, demonstrating a large circular movement. Additionally, when encountering a boundary, like the wall of a box, it will travel along the boundary. This behavior could be particularly useful for mapping unknown environments. Its behavior is governed by physical intelligence, which means that its actions are determined by its structural design and the materials it's made of rather than being directed by a computer or human intervention. The researchers could fine-tune the twisted Ringbot's behavior by modifying the device's geometry. They could change the direction of its spin by twisting the ribbon in different ways. The speed could be adjusted by altering the width of the ribbon or the number of twists. The researchers conducted proof-of-concept testing and demonstrated that the twisted Ringbot could navigate through confined spaces by following its contours. Researchers were also able to map the boundaries of more complex spaces by introducing 2 twisted Ringbots into the space, with each robot rotating in a different direction. This enabled them to capture the contours of the more complex space.